6. Have those questions ready, kiddos, that you guys, okay, that you guys had just a moment ago. But number 6, final answer should be, I think, -3. Do you guys get that?
Yeah.
Perfect. How hard was that one? Not too bad. You could have done it the old way or the new way. You could have done it with factoring, or you could have done it with L'Hopital's. Both ways work. Number 6. Number next one would have been number 16. Number 16, final answer should be 3/2. Final answer should be 3/2. There were a few different ways of doing it. One way is you could take the derivative of ln of x cubed. The other way is that you could have brought down the 3 from the power property of logarithms. That would have been nice. And then you end up with an x that would pop down, but then when you plug in 1, you'd end up just with 3/2. Next one is number 32, which I think is right over here. Final answer is 0. Now, guys, was this a normal L'Hopital's one? Why not? Are you allowed to even use L'Hopital's? If you plug in infinity to the bottom, you do get infinity, right? If you plug in infinity to the top, question, how high does sine go? It doesn't. Sine goes in between 1 and -1, which means in between 1 and -1 over infinity is not L'Hopital's. I know, crazy, huh? So, how could you have done this one? One way to think about it is to think that sine of x is going to be in between 1 and -1. Sine of x is going to be in between 1 and -1. So if we want to find this guy's limit, then question, what should we do to everybody else? And guys, how are we going to take the limit of both of the ends, or both of the sides of sine of x over x minus pi? And bottom wins. So what's 1 over infinity? Or what's bottom winning? 0. What's bottom winning, or 1 over infinity?
0.
So what is this answer going to squeeze to be? It has to be greater than or equal to, and less than or equal to. It has to be equal to. I know, it was mean. A little bit mean. L'Hopital's was illegal. I think someone asked me yesterday, right, Tyler? Are you going to be able to use L'Hopital's on every single one? And I said, most, but not that one. We have one more, right? Number 58? Double check me, is that the only other one?
Yep.
Okay. Number 58 gives us the following. The indeterminate form was infinity minus infinity, which is indeterminate, true? The indeterminate form was infinity minus infinity, which is indeterminate. So what did they do to try to get it into L'Hopital form? Common denominator. Common denominator. So if you put it all together.
Yeah, I don't have that. I don't have that.
I do.
Okay. Does anybody have their textbook?
Do you have x minus 2, Sean? X over x minus 2.
I have the limit of x approaches 2 from above of 8 over x squared minus 4 minus x over x minus 2.
Huh. What's that?
58.
No, that's not right.
Definitely.
You guys did 57. Whoever has 8 over, you did
Is there into
57.
infinity?
Maybe. Check it
I have
out.
-1.
Yikes.
For 7.7, number 57, which is the 8 over 1 that you guys accidentally did, that would have been
Wait, I think I still even have that.
-3/2. 57 would have been -3/2. I'm double checking, is that B is solve?
Yeah.
Yeah, -3/2 for 57. Unless you wrote part of 57 and part of 58,
I
then you
think
might
that's
be.
probably what I think that's what I
Yeah.
I do that one.
Okay, so this is the proper one. This is the proper one. As it is, it'd be 1 over 0, which would be infinity. Coming from above, that would be a positive infinity. We didn't deal a lot with above or below. But basically 2 point something, that's going to be a positive number, not a negative, when you go to check the sign. This one, 2 from above, that's going to be a positive, that's going to be a positive, but the bottom wins. No. We're not going to infinity, sorry, we're going to 2. So it's gonna be 1 over 0. The bottom wins, this is a positive, is being subtracted, so minus infinity, it's indeterminate. Long story short, guys, they have common denominators, what should we probably do? Put them together, even if you aren't quite sure what to do here, go here and then say, okay, 2 minus 1 is 1, 1 minus 1 is 0, over 0. Now I know it's indeterminate, even if I was a little fuzzy up here. So this one's going to equal 0 over 0. What do we do with 0 over 0? You could multiply by the conjugate if you want to try the old-fashioned way. Or the new-fashioned way would be, aka L'Hopital. Take the derivative of 1 is 0, take the derivative of this to the 1/2. Bring down the 1/2, make it a negative 1/2 power. Derivative of this guy is 2x. And then when you simplify, now you're able to plug in. 2 times 4 is 8, 2 minus 1 is 1, negative 1/8 is your final answer.
I mean, I got different.
But the derivative is this, the derivative is this. Do you mean how to go next step?
Yeah.
Okay. This would be the same thing as the limit as x approaches 2. I'm going to use my trick. My trick says when you have a complex fraction, what do you multiply top and bottom by? Multiply top and bottom by the innermost fraction. So then that cancels, and you end up with 10.
Can you times 2x?
No. Because if you times 2x, that'd be 4x
You
squared.
would need to multiply by 1 over 2x.
You could multiply by 1 over 2.
That's it.
You could multiply by 1 over 2. But this is the innermost denominator, so I multiply top and bottom. That was our last even. Now, kiddos, I heard you talking about odds. So, where were the odds odd?
51.
51. Is that the worst one? Everyone agrees?
That's what I batting.
37.
27. Okay, let's go peek at 27. Okay.
Actually, I just have one question about it. So number over infinity is 0, right?
Yeah, because it's
The limit
be,
of the number.
The bottom wins.
Okay.
And whenever bottom wins,
so
0.
that's why 50.
So in this one, when you get here, this is what you're looking at, right, Charlotte, and you keep going. Number over infinity, bottom wins, think degree test.
Okay.
Think degree test, since the bottom wins.
And 1 over 0 is infinity.
Yes. Because if you go 1 over 1/2, it's 2, 1 over 1/3, it's 3, 1 over 1/10 is 10, 1 over 1/1000, it's 1,000. So as you get closer to 0, the fraction flips and it ends up making a huge number. But we also memorized when you have number over 0, it's a vertical asymptote, so you know it's going to either positive infinity or negative infinity. We called it infinite form back in the 0 over 0 indeterminate, number over 0 is infinite.
If it's negative, it's still positive, right? I mean, the number over.
You have to check the sign. So if it's positive over positive, then it's positive. If it's positive or negative, then. In this one, guys, it didn't look like 0 over 0 or infinity over infinity. Wait a minute. What happens when you plug in infinity? It's going to be infinity times, and what's ln of infinity? Ln goes like this. Doesn't it go to infinity also?
Yeah,
So it's going to be infinity times infinity. Did you guys look at your indeterminates?
It's not.
It's not indeterminate. Infinity times infinity, ever bigger times ever bigger is going to be ever bigger.
Oh,
It's not indeterminate. Infinity times infinity is not indeterminate.
I thought it was.
Can I check out those forms? I'm L'Hopital. Okay, last one is number 15.
For the 43, can we do like, I don't know, I just do a weird thing. I derive the x.
No, you're not allowed to. Not L'Hopitals.
Okay.
Yeah, not L'Hopitals. Sorry. Number 51 is the last one you guys had a question on.
Yep.
And that was the one with the weird e's that you guys didn't get to listen to me solve unless you watched the video like I told you to. So here's the long story short with number 51. Let me just go to the notes. This is the one that you didn't get to watch me finish. This is on the video from period 6. And the notes that are loaded online are from period 6 as well. You can hear me explaining it just as if it was a pink number and you go watch a video online. So let's instead go ahead and talk about number 51 because that's what you guys have a question on. So what was number 51's problem?
The limit as x approaches 0 from above
Wait, does that change anything, by the way, like if you have above?
Basically, it just makes it legal when you put an ln in. Because if it was from below and it's an ln, we're in trouble. What do we have as our function?
1 plus x to the 1 over x.
Here's the long story short. When you go to plug in 0, you're going to end up with 1 to the 1 over 0 from above, which makes this a positive, which is going to be 1 to the positive infinity, which is indeterminate.
Oh my gosh, it's a rule.
So therefore, what I can do is the following. I say, take this guy and say, ew, I don't like this. So I say, okay, let's set y equal to, for the express purpose of, yes, I need to find the limit. That is true.
Do you put I on
You need to take a limit. However, if I have two sides of an equation, I can put an ln in. And the purpose of putting an ln in, and I'm just going to actually leave that ln out. I don't need the ln to go in on this side. This is the guy I'm trying to find. This is my goal right here. Is the limit of the original function. But over here, I need to change this guy up because the way he's written is not working. There is a limit property that says f of a limit of g can be the limit of f of g, so I can bring the ln in. And when I bring the ln in, what happens to that 1 over x? It can come down. And when it comes down, then I'm able to go ahead and say, all right, in order to solve, let's go ahead and plug in chug. When we plug in chug, don't we have a top and a bottom? If I plug in 0 from above, which ultimately just plug in 0. 0 from above, ln of 1 is 0. When I plug in 0 below, 0. 0 over 0, don't be tells. So I can go ahead and say, okay, this will be the same thing as the limit as x approaches 0 of derivative of the top will be 1 over u times u prime. Derivative of the bottom will be 1. Go team.
Yes.
Because now I can plug in 0. That's going to be 1 times 1 over 1 is just 1. So I can go ahead and say this side equals 1. But the dilemma is what's over here still.
The ln natural.
ln of the answer that I want. ln of the answer that I want. So if I want this guy, I have to undo this guy. So what am I going to do to both sides? Let's throw in. Now I can say the limit as x approaches 0, positive of y, which is the same thing as the limit as x approaches 0, positive of who y was.
That makes sense.
Equals e. Okay. With that, kiddos, let's not even do a spot check today, just for the sake of, I'll get you points tomorrow, I promise, for sake of time. Let's go ahead and clear off all of our desks except for the blank piece of paper and the pencil.
Is the blank piece of paper a cover sheet?
I'll give you a hint. Any limit problems on the quiz, you can use what we titles on. I think I can give it to you in instructions. That way you don't have to worry about, ooh, is it one of those tricky ones that I can't. You guys have that blank piece of paper?